This is good evening, friends. This is the very first problem we are going to solve it on block friction. You take the problem. The problem is block is kept on the floor and its weight is 800 Newton. And it is pulled by a force P, which that P is inclined 35 degrees to the horizontal. So, what is asked in this problem, block friction? While pulling this block to the right side, what is the force P if the coefficient of friction P is equal to what? If the coefficient of friction mu is equal to 0.25. So how to solve this problem? While it is a limiting friction, while pulling this block to the right side, there will be a frictional force to the left side acting towards left side. So this block, we will draw a free body diagram. So before drawing the free body diagram, you should know this P can be resolved into horizontal and vertical components. That is P cos 35 and P sin 35 vertically. So the forces acting on the particle on the body is considered as a particle here. On the body, the downward force 800 Newton, that is the weight, and there will be a reaction against this, that is a normal reaction N, and this P resolved into two components. The horizontal component is P cos 35 and vertical component is P sin 35. And against this movement to the right direction, there will be a leftward frictional force acting in this, that is F is equal to mu into N. Now what is mu here? 0.25. 0.25 into N. So we will find out what is cos 35. Cos 35 is 0.819. So it will be 0.819p, and this will be sin 35 will be 0.574. 0.574p. So we will draw a free body diagram in this as a particle diagram. So you can see here there will be a downward force, upward force. There will be a vertical force, horizontal force, right side and left side. So here you can see this force N plus P sin 35, that is N plus 0.574p is acting vertically upwards. Downwards there will be 800 Newton. Right side you will be having 0.819p. Left side you will be having 0.25n. 0.25n. Now this block, for equilibrium we can solve it. Equilibrium of a particle in two dimensions. What are the conditions to be a particle to be in equilibrium in two dimensions? The first condition is summation of f of x is equal to 0. So f of x component is 0.819p minus 0.25 n is equal to 0. This is the first equation. Summation of f of y is equal to 0. In this equation, y component you can take, this is positive, n, that is 0.574 p plus n is equal to, that is minus 800. Minus 800 is equal to 0. So I can take this as 0.574 p plus n is equal to 800. So you will get two equations. This is the first equation and this is the second equation. So by solving these two equations so how many unknowns you have? P and N. So two unknowns you have, two equations you have, very well you can solve it by calculator. By solving that, I can find out P. P is equal to, I am getting it by solving this, P is equal to 207.792 Newton and N is equal to 680.72 Newton. So this is the very first problem I'm solving for block friction. Thank you.